Generally speaking, I like to try to do a variety of examples when I'm doing problems like this for practice, including problems that have exponential or log aspects, as well as some trigonometry aspects. So when you're choosing problems to do on page 27 and page 28, try to pick a nice variety and try to include some of those kind of funky functions like ln or sine or cos, just so that way you can kind of adapt your strategy to a variety of functions. It's very common that in all levels of calculus, college, AP, or beyond, that you're generally going to see all functions equal opportunity. So try not to pigeonhole yourself into doing one type of example over and over again. In letter G, we'll deal with the ln function because hopefully by now you've kind of picked up on a very important aspect of ln in u sub specifically. And it's the fact that the derivative of ln is 1 over x. Oftentimes when ln appears in a u sub question, so namely a chain, a quotient, something that looks like this, you can almost be guaranteed that if there's a fraction with an x on the bottom, it's meant to have u as ln somehow. So that usually is a pretty big clue for this problem that I'll want to choose 1 plus ln x as my u sub. The obvious kind of logic behind that from our previous conversations is that 1 plus ln also happens to be the inside of the chain rule. So again, it kind of makes sense both ways. But it is important to note that every time you see an ln problem, it's not really a coincidence that there's an x in the denominator of a fraction. Check out question letter D if you haven't already. It's almost the exact same thing. Notice there's a hidden little 1 over x in the problem, which tips you off that ln is going to be a good u sub. So that logic does kind of spread through multiple questions, and that's kind of nice. Once you pick up on those little details, you'll find it helps you in a variety of settings. In this particular question, I'm going to choose my u sub as 1 plus ln x. And just like I did in the previous examples, I'm going to take this opportunity to do a full conversion. I'm going to go all in terms of u, so I don't have any x coordinates to have to worry about. I still like to do my substitution step by step, but if you want to take some liberties with the order in which you do some of these steps, feel free. So initially what I'm seeing here is 1 plus ln x cubed. And then I'm seeing 1 over x dx almost as like a separate concern. So if I was to rewrite the problem in my head, or even literally just as a bit of scratch work up here, I can see that I'm going to need to separate these things so that I can get the u sub to happen on its own, and then the du sub to happen sort of organically. So I can tell that by rewriting the original problem not as one single fraction but as a product, I can sort of force the substitution to happen a little bit cleaner. Now, if I make my initial substitution for the chain rule, 1 plus ln x is going to substitute into the cube, so I know I'll have u cubed. And then I have this 1 over x dx that I know is going to substitute in the next step. I'm also in the next step going to change the limits, but I'm not going to worry about that quite yet. I'll just go one step at a time. Back to my side work then, I want to take the derivative, so du equals 1 doesn't have any notable derivative, but ln x has a derivative of 1 over x dx. There's my substitution. So I know this is going to work out really nicely. I have the integral, I have u cubed, and now I have a du, all substituted cleanly. Now my last order of business before I officially do the antiderivative step is to convert my limits. So again, to my side work, I have x equals 1 that needs to be converted and x equals e. You can do them one at a time, or you can write them both and just kind of do them in any order you want. Doesn't really matter. Now x equals 1 means that I have to plug 1 into my original u sub. So again, I'll just refer back with a bit of a highlight there so you can see where I'm getting this information from. I'm going to plug the 1 into the x spot in my u sub, and I'm going to convert to terms of u. So that means u is equal to, now I have 1 plus ln 1. Now again, the implication is that you should be doing this without a calculator, so hopefully you'll remember ln of 1 is 0, so 1 plus 0 is 1. Same thing goes for plugging in e. I'm going to do the same thing with the other original x coordinate. I'm going to plug it into the u sub so that way I can convert it to terms of u. Now if I convert by plugging in, I'm plugging in 1 plus ln of e. And just to remind ourselves, ln of e is 1. So 1 plus 1 is 2. Now you'll notice, and this is not necessarily a coincidence, this happens a lot, that when you convert the problem in terms of u, including the u coordinates, it usually ends up looking a lot cleaner than the original problem. That's another reason why I like this strategy, is because you end up with a much simpler antiderivative. This is just going to be a power rule, and very simple numbers to plug in. That's not 100% true 100% of the time, but it's definitely true most of the time, to the point where I would say it's worth it to kind of keep it as a good rule of thumb. So off to my easy calculus now. I have u cubed, which is just a power rule antiderivative to do. That's going to be 1/4 u to the 4th, and evaluated at 2 and at 1. Remember, you don't have to write the plus c. It's just going to cancel out anyway when you subtract, so save yourself that step. Now we're going to plug in, and again, you can show as much or as little work as you need to when plugging in. Just make sure you're being careful. I have 1/4 times 2 to the 4th minus 1/4 times 1 to the 4th that I need to simplify. Nicely, 2 to the 4th is 16. 16 divided by 4 is 4, minus 1 to the power of 4 is 4, times 1/4 is 1/4. So it's not the prettiest for sure, but a quick common denominator might be all you need. You can call 4 16/4 minus 1/4, and the overall answer ends up being 15/4. It's not wrong to leave it as 4 minus 1/4 either, by the way. If it was an FRQ, you would get full credit for writing 4 minus 1/4 and not taking the time to do the extra common denominator, even though it is technically a mathematically easy step. I do understand it's one extra thing, and this is a calculus class, which means we care a lot more about this section than this one. So if you don't take the common denominator opportunity, that's okay. Again, just in terms of big picture understanding, you just found the area underneath this crazy graph in the region or the interval from 1 to e. You can see why geometrically that would just be a bear of a task. There's no way that we would even predict what this graph looks like, let alone be able to find its area with traditional geometric shapes. So again, you're starting to hopefully see the connection and the necessity for being able to do proper algebraic antiderivatives. This is going to do the job when geometry can't. Now, in one more subsequent video, I will do a trigonometry example, although I will give you a heads up that many of the trigonometry examples on this page, like letter E and letter H, do follow a very similar substitution pattern to letter G. If you want to kind of keep things consistent for now, and if you want to do problems that just feature ln, letter D is another good one if you haven't yet tried that one, because the substitution pattern there is, again, very similar. As you're practicing, don't forget to check your answers on the key, because even though the answer on the key is its most simplified, hopefully it'll kind of force your hand at trying to do the cleanup steps, which I do think for those of us going on to college calc might be worth practicing, even though I know it's not a mandatory step for the AP.